Hello. So, first version of the sophomore dream, which is this integral from 0 to 1 of x elevated to the power of x dx. We want to prove that that's equal to minus the sum from m equal to 1 to from 1 to infinity of minus m to minus m. This is x to x. Before x equals 0, we need to go to the complex plane to have this function, and thankfully we will not deal with complex analysis because it's a spiral in the complex plane, but it's quite a lot more complicated than there. And this integral wouldn't make this sense really here in this instance. This is x to x, it's 1 when x is equals 0, it's 1 when x equals 1, it has a minimum at 1 divided by e, the value of the minimum is here, and our integral is up to this point here between this 0 and this one part. So we have this. First thing we're gonna do is putting this x in the exponent together with the other x, so that we have e to x ln of x. Then we expand this in its infinite sum form, so that we have the integral from 0 to 1 of the sum from 0 to infinity of x ln of x, all of that to the power of n divided by n factorial dx. And since this is a continuous function in this interval, it has uniform convergence, so we can invert the sum and the integral. So the integral of the sum is the sum of the integrals as per usual. And then we have the sum from 0 to infinity, from n equals 0 to infinity, of the integral from 0 to 1 of x to n ln of x to the power of n divided by n factorial dx. And then we finally do a variable substitution, and this is the main point here. So the variable substitution is going to be x is equal to e to minus u divided by n plus 1. This means that x to n is e to minus to the power of minus n times u divided by n plus 1. The x is minus 1 divided by n plus 1 e to minus u divided by n plus 1 du. When x goes to 0, u goes to infinity. When x goes to 1, u goes to 0. And ln of x to n is the ln of an exponential, which is the argument to n. So it is the argument to n, so minus u to n divided by n plus 1 to n. We collect all those terms and we go to the next step, which is getting the similars together. So I have, after a few cancellations and putting other things together, the sum from 0 to infinity of minus 1 to n plus 1 to minus n plus 1, and the integral from 0 to infinity of u to n exponential of minus u du. This is the definition of the gamma function, so this is gonna be n factorial, which is gonna cut to this n factorial. So we are finally very close to the sum that we wanted, the sum from 0 to infinity of minus 1 to n plus 1 to minus n plus 1. But we're gonna need to do an index change. N plus 1 is gonna be equal m. So when n is 0, m is 1. When n is infinity, m is infinity. And we get this, the sum from m equal 1 to infinity of minus 1 to m plus 1 times m to minus m. But remember that via parity minus 1 to m minus 1 is equal to minus 1 to m plus 1, which means that the sum from 1 to infinity of minus 1 to m plus 1 times m to minus m is the sum that we want already, which is minus the sum from m equal 1 to infinity of minus m to minus m. We put this minus together with this m. And just like we wanted, we proved this. There is another sophomore dream expression, which is x to minus x, but that's going to be a future vid. Bye for now.